Yes. Today, let's check lighting too, and lighting and centering. That's not bad. We'll have to move this a little bit during the course of the day. And this PowerPoint I will have linked for you guys ASAP. And when I say ASAP, I mean within half an hour of class being over. Because I'm going to go straight upstairs to my office, close the door before my negotiations meetings kick in, which depress me, and I'm going to upload your lessons to you, which makes me happy, and hopefully get another quiz or two written for my other classes. So anyway, you don't have, this is about a 20-page or 25-page PowerPoint presentation. We're going to intersperse it with work on the board. So it's not just me reading off this to you the entire time. There's a few terms in here, but you'll have this whole document ready for you guys in a couple hours. So you don't have to write down anything if you don't want to. It's all going to be available for you. But I did want to make it available to you, and not tell you can't take notes, but just realize, don't feel that you have to like race to keep up with this. It'll be waiting for you later if you just want to let the class kind of wash over you. So I call this the Intro to Probability and Statistics, and if you look at that extra resource or homework link, the first topic is called Intro to Probability and Statistics because, well, every textbook, including the one that I've linked for you guys, which some of you might never look at, that's totally fine if you don't. I think they try to teach too much too soon in those books. Here's an example. There's a thing called a z-score, which is wickedly important in statistics. Wickedly important. We're going to start using it in 244 next week, and we're never going to stop using it. It's pretty much the way you do what's called normalizing data. You take a bunch of different data on different scales and bring it down to the same scale. So you can argue about different measurements and different scaling systems and see which thing rises to the top. It's a very important tool. We won't need to talk about it, I'm guessing, until like week 7 or week 8, somewhere in there. But almost every stat textbook I've ever seen teaches it in chapter 1. And then says, and when we get to the normal distribution in chapter 6, we'll recall this formula. I'm like, who will recall this formula? Will you guys remember something that you learned today and that we don't use again for 6 weeks? I won't. Hell, I won't remember it 5 minutes from now. So rather than do that, what I've done is I've kind of looked at your textbook as a guide and said, okay, that's important right now, that's important right now, that can wait. That waits till we talk about percentiles, that waits till we talk about ranking, that waits till the binomial. And I've extracted kind of the stuff we're going to start needing like Tuesday together. So that's what today is all about. It's about a filtered down look at some pre-ideas. Most of them are graphic, ways to put data, and I didn't know how to define data, so I'm going to call it stuff we collect. We're interested. Give me some ideas of data that you'd be interested in collecting. What kind of data would you be interested in collecting? There's a hint. It still smells like grape. Yeah, well, I got it taste. Yeah, great. I thought it was. What was the comment, the snide comment I made after Trey tried to poison me? Oh, I'm sorry. What was that snide comment I made? Trey tried to poison me, right? What might be some data I'd be interested in about these apples?
What type they are?
Percentage GMO, which Trey completely squashed for me when he said 0. Good. What did you say, Tiger?
What type of apples?
What type of apples, right? Good. What type of apples? Is it a Macintosh? Is it a Honeycrisp? Is it something else? Good. Type of apple? Percentage of GMO ingredients?
Location where it was grown.
Location, geographic location where it's grown. Nice.
Pesticides?
I'm going to stop eating because I'm going to start spitting. Pesticides! Percentage pesticides used across the field. Maybe number of... How do you measure pesticides on a fruit? Is it number? Do they measure pesticides on a fruit? I always think it's cute when people say, make sure you wash this before you eat it. Like that's going to wash off a pesticide. It's in the roots. It's inside the damn thing. Wash it off. I think it's adorable. You wash the dirt off me. Right. If they use a systemic, of course it's ridiculous. If it's something on the outside, but I mean, is water going to knock it off? They irrigate those things too.
Yeah.
I mean, it's kind of funny. You irrigate an apple tree. You think washing it under the sink is going to be like for 3.5 seconds going to knock the pesticide off? There you go.
I wash my apples because you don't know who touched them up.
I call that free immune boosting. That's what I call that. My son drops his dinner on the floor. You eat that. We used to hand him when he was 18 months old. We take him to the rock climbing gym, which is in itself a biology experiment. And every 8-year-old girl just wanted to kiss all over him, like, go get him, go get him. And, oh, Max, go, you're saving me medical bills later, go. I'm with you, sister, I'm with you. Get the dirt off of there, or eat it. He doesn't eat anything yet that hasn't killed him, or that has killed him. Okay, so I love the data you guys just threw out there about the apples. Trey, you mentioned type of apple, location, tell me your name again.
Linda.
Linda, thank you. Geographic location. That's what is technically called qualitative data. It's not number data, it's some kind of attribute. So what type of apple? Honeycrisp, or Gala, or Jonah Gold, or whatever that was, something girl, early girl, that's a tomato.
Daisy.
Daisy, girl Daisy, whatever the hell it's
Daisy
called
girl.
over there on the sticker. But when you name the type, or even the fruit itself, apple, pear, plum, nectarine, those aren't numbers. I mean, you can put a number next to them, 1, pear, 1, 2, apple, but it's still just words. It's called qualitative, or attribute. And basically anything you can list down by without using numbers. This also happens when you guys do your student evals for classes. When they look like numbers on those evals, but the first couple questions on those student evals you do you disagree or agree with the following statement? And then usually you circle from 1 to 5, 1 to 5, 1 to 5. Those look like numbers, but they're not numbers. They're words. When you circle 5, that means you strongly agree with the statement. It is not the number 5, it is the word or the phrase strongly agree. Now what's interesting is those numbers are then averaged, which I think is silly, but we'll get more to that in this course too, about what you should and shouldn't do with data. Right? But that's coming, that's coming. So, qualitative, good. There's not a lot we can do with that. We're going to see as the day progresses what you can do with qualitative. You can count it. How many Gala, how many, whatever the hell kind that is, how many pears, how many nectarines, how many Ford Explorers in the parking lot, things like that. Right? You can count those and graph them. But other than that, there's not a lot you can do with them other than just kind of counting and graphing them. So that's qualitative data. And we mentioned other stuff. Number of GMO ingredients, or percentage of the ingredient list that is GMO. Well, that's something that that does have a number attached to it, doesn't it? It's got a number attached to it. If you have 10 ingredients that are all equally used in a product, and 3 are GMO, that means 30% of the ingredient list is GMO, if they're all equally used in the product. I love looking at Larabars. You ever had a Larabar? There's like no more than 3 ingredients in them. They're the most amazing things ever. It's like apples, plums, walnuts. That's it's a little tiny block of food that has 3 things in it. Incredible, incredible. So that, you could say, okay, so what percentage of that is GMO? Well, it's 0, because Larabar wouldn't do that. That's the whole point of their company.
What's GMO?
Genetically modified. What's the O stand for?
Organism.
Organism. Oh God, that makes it even worse. I never knew what the O stood for. Organism. I don't think any research is conclusive that it's actually bad for you. I think I get nervous when I see things like hydrogenated oils. Like they insert the hydrogen ion to make something have a longer shelf life. It's like, oh my God, like rot is a part of life. Like that's the reason we have forests, is because things fall down and rot and make new soil. We're gonna keep this. I saw a video once, I think it was Fast Food Nation, they put a plate of French fries out for like 3 months, and it looked just the same 3 months later as it did the first day.
There was another one where they did it for like a year or 2.
A year?
And it was still the same.
It's like, God, something just kind of rubs me the wrong. No, as far as I know, no research has shown yet that it's bad for you, but something just, I don't know, man. Something just feels like it's cheating our liver. I don't know. Anyway, back to this opposite of qualitative data is what we like to call numerical or quantitative. This is the fun stuff that we play with in this class. This is the stuff we can actually count, measure, and have fun with. And I like to break it into 2 different classes. And it was funny because I was just having this discussion with 244 earlier. You can count data or you can measure data. You can count it or you can measure it. Right? You can count it or you can measure it. So in other words, recently we're going to attack a problem in this class later on about when you buy chickens. We talked about this in 105. You buy chickens from a feed store, and you hope to get girls if you want eggs. But it's a crapshoot, because when you buy a baby chick from a feed store, it's not 100% guaranteed that that baby chick is a female. It's usually given to you as 90%. At least that's the number that was given to me when I go to a feed store. 90%, 90%, 90%. So if you buy 4 chicks, a quantitative, discrete value you might be interested in is how many of those chicks are going to grow up and be girls. It might be as few as 0, it might be as high as 4, or anything in between. Only way to find out is to let them grow up and then see if it grows big velociraptor-like claws on its back and attacks you when you go in the chicken coop. That's one way to find out. Wait around, we're still waiting to find it out. They look like girls so far. We'll see. We'll see. So that's a discrete data value. How many of the 4 girls that we bought, are going to grow up and become girls? I mean, not girls, I put girls quotes, because they're called pullets, which means they've been sexed as a female. This is different than qualitative data. Qualitative data would be like, what kind of chicken did you get? Did you get an Orpington? Did you Did you get an Americana? Did you get a Sussex? That would be a qualitative thing. But this is, okay, you bought 4. You bought 4 of these. Of those 4, how many grew into girls? Okay, so that would be a discrete data point. What would a continuous data point, a measurement, using the same chicken analogy maybe? What would you be interested in measuring, perhaps?
Size of their eggs.
Good! I was thinking the exact same thing because Marge, our Orpington, tell me your name again.
Katie.
Katie, thank you. Our Orpington just laid, have you seen this before? She's getting old, and she's starting to lay very interesting things, like sometimes an egg without a shell, which is messy. She laid Orpington, she's not an Orpington, she's an Americana, I'm sorry, Americana. They lay Easter eggs, green, they're greenish blue, they're fun. She laid this thing that was like 1.5 times the volume of the egg she usually lays. So the first thing I thought was like, poor girl. And the second thing I thought was, what the hell is in there? Did she self-fertilize an egg? Because 1 in 10,000 chickens have male and female parts. So then I start having these nightmares about breeding more chickens. Crack the thing open into a bowl. Out falls the yolk and the albumin and a small secondary egg in a shell.
Wow.
Who keeps chickens? Does that happen often? Okay. Okay. I Googled egg within an egg and I got some disturbing results. I didn't look at any. I think I'm going to ask some people if they've seen it before. And there's another big egg in the fridge from a couple days ago sitting there waiting for me, the same size, the same shape, and I got a Martian for a chicken. So, yes, volume of the egg, the consistency, on a color scale perhaps, the yolks. You ever seen a perfectly free range, like a backyard chicken egg yolk versus a store-bought?
They're so much better.
Darker.
They are bright
Bright
orange
orange.
or dark orange, depending on what they're eating. I mean, when they eat, when they pick up, it's incredible. I cracked 2 of ours and one of our neighbors had a borrowed egg to make some cookies, and she had a store-bought egg, an organic, free-range store-bought egg. Cracked R2 next to that one. I'm like, oh my God, it's like night and day. So you could put it on a color scale. That would be a quantitative measure, a quantitative continuous measure. Good. The volume, the size, the weight of the bird. Weight of the birds. Put them on a scale. I mean, they're mostly air, from what I can tell. So discrete, you count. Continuous, you measure. As far as I can tell, there are only 4 things that are measured. We mentioned a couple of them, right? Size, which would be loosely defined as, well, you can do a couple different ways. What's one thing that you can measure size like? Do torque fit all the time. What's one size variable or size unit that you measure?
Length.
Length, good. So any kind of a distance. So we measure 200-yard wind sprints. So a length is 1. What's another size thing that you can measure?
Width.
Well, I'm going to call width the same thing as length. It just depends on what you call it. So a distance,
Yeah.
height, I can call that width too.
Two,
Just turn your
okay.
head sideways. So just distance in general.
Okay. Miles.
Distance.
Wait.
Okay.
Weight, that's different, isn't it?
It's different.
Weight's dependent on mass.
No.
So your mass depending on the force of gravity. So you got weight, you got distance. Good. Time, I like time. I mean, I like time too. But yeah, I think we measure time, right? How long something takes. That's a continuous measurement. What's the last one?
Volume.
I like volume. I'm going to call that distance, if that's okay, just because it's distance cubed. It's length times width times height. Is that fair? I always try to make things simpler than more convoluted. So we can call volume another variable, but really it's just cubic length. So we can call, and it's also the same as weight if you think about it that way. Apply a density to it. So we got time, weight, distance.
Motion.
Say that again.
Motion.
Motion's kind of like distance and time together. So it's the change in distance. So it's still distance. And if you're whoever said motion, I love that vote. I'm going to call it, if you don't mind, tell me your name. Sean, thank you. Mine too. I'm going to call it a measure of distance. Wait, we'll give you the time. How many skiers in here? Snowboarders. That's not a good hint.
Speed.
Speed's distance.
Temperature.
Time. Temperature! How many of you go out skate skiing? Put too many layers on. I do that every time I go out. It's 22 degrees in the car. Holy crap, I'm freezing. Put my long sleeves on. I get 3 miles out on the course. I'm sweating like a banshee. Yes, temperature. That's something else you measure. That's unique from the other 3. I can't find a 5th. Those are the 4 I've seen. Distance, weight, time, and temperature. Everything else is some combination of those. So, make sense? There's our data. This is what we have the most fun with, and we'll have plenty of fun with that as we go through the next 9 things together. All right. Now, one of my students in 244 on Tuesday said, what is the difference between Math 243 and Math 244? I said, that's a freaking fantastic question. And I forgot that we actually talk about it at the beginning of 243. 243 is really centered around what's called descriptive statistics. which means we get a bunch of data, collect it, and then report back on it. Okay? This is one of my favorite reports of descriptive statistics that I've seen recently. This is the results of the 2012 presidential election by state.